Hi mga ka-analytics! I hope you're all doing great. Midterms week is fast approaching and it's the perfect time to sharpen our knowledge and skills. I'm Crystal, your presenter for today, and I'm excited to guide you through classification and model evaluation. In this short discussion, we'll explore why it's essential and how it applies to real-world scenarios. So let's get started.
First, what is classification? A classification is a type of supervised machine learning method where the model tries to predict the correct label of a given input. It is a data mining task of predicting the value of a categorical variable by building a model based on one or more numerical and categorical variable. So here in this figure, may makikita tayong table. This column represents the target variable, or another term is yung class. It is also a dependent variable, usually isa lang siya. Then this column naman, nagre-represent naman siya ng predictors. Ito naman yung factors affecting your target. This one represents the categorical or the numerical variable. Next, for the learning algorithms, first is the supervised machine learning. It is the input data comes with an expected output. So pag sinabi nating supervised machine learning, ito yung may target tayo. Kumbaga, meron tayong alam na output. So, commonly types ng supervised learning algorithm is yung classification, then yung regression. Then for the algorithm naman is yung neural network, decision trees, linear regression, and support vector machines. On the other hand, kapag naman sinabing unsupervised machine learning, it identifies hidden data patterns from an unlabeled data. So, kung yung kanina supervised, may target variable, dito hindi natin alam kung ano yung magiging output niya. So commonly types naman ng unsupervised learning algorithm is yung clustering and association. Then for the algorithm use is yung hidden Markov models, k-means, hierarchical clustering, Gaussian mixture models. Next, for unsupervised is the reinforcement machine learning. It is a learned series of actions react to an environment on their own. Common types ng reinforcement learning algorithm is yung exploitation and exploration. For the algorithm naman na ginagamit is yung mga temporal difference, deep adversarial networks, and yung Q-learning. Moving on naman sa types of learner in machine learning classification. So, merong dalawang type ng learning sa classification. First is yung eager learners and then the lazy learners. Yung eager learner, ito yung machine learning algorithm that first build a model from the training dataset before making any prediction on future datasets. While yung lazy learner, hindi sila nag-create ng model immediately from the training data, and this is where the lazy aspect comes from. So, yung difference nila, yung eager learner, they spend more times during the training process because of their eagerness to have a better generalization during the training from learning the weights, but they require less time to make predictions. While the lazy learners, minimemorize nila yung mga training data, and each time there is a need to make a prediction, they search for the nearest neighbor from the whole training data, which makes them very slow during prediction. Yung common algorithm na ginagamit sa eager learner is yung mga logistic regression, support vector machine, decision trees, and neural networks. For the lazy learners naman, yung common algorithm na ginagamit is yung instance-based learner, local regression, k nearest neighbors, and then the lazy Bayesian rules. Next is yung application in real-world scenarios ng classification. In healthcare industry, pwedeng i-apply indices diagnosis. For example, nun is yung identifying the cancer types from medical images. For finance naman, pwedeng apply yung fraud detections and flagging suspicious transactions. For the retail, it is yung customer segmentation, which categorizing the shoppers for targeted marketing. Then technology, pwedeng i-apply is yung image recognition, classifying the objects in autonomous vehicle. Next, for the types of classification, first is the binary classification. It is the fundamental aspect of machine learning, categorizing data into two distinct classes. The algorithm generalizes the decision boundary separation between two classes and apply to unseen data, classify new instances into one of the two classes correctly. Yung method na to is essential for tasks like spam detection. Common algorithm na ginagamit is yung logistic regression, SVM, which is yung support vector machines. When we say regression pala, it is the straightforward yet effective tool for classification. This approach is effective when a simple yes or no decision is necessary. Kapag naman support vector machines, it works well in both linear and nonlinear classification. Next, decision trees. Ito yung flexible and handle nonlinear data well. Next is for the random forest. Enhanced lang siya ng decision trees by combining several trees, leading to more accurate predictions. The next is the neural network. Inspired by the human brain, these models use multiple layers of neurons to learn complex patterns, making them more powerful for deep learning applications. Then, next naman, yung last na common algorithm is yung Naive Bayes. It is swift and effective, especially for text analysis. Next type of classification is the single label multi-class. The algorithm predicts a single label or category for each input instance from set of two or more possible labels, including the image recognition, natural language processing, and sentimental analysis. So, just like the binary classification, same lang sila ng common algorithm na ginagamit. Next type of classification is the multi-label, multi-class classification. The algorithm predicts the multi-labels of categories for each input instances from a set of two or more possible labels, including dito yung mga classification, text classification, image recognition, and yung recommendation system. Ang common naman na algorithm na ginagamit sa multi-label multi-class is binary relevance. It treats each label as a separate binary classification problem. simple but ignores label dependencies. Next is the label power set. It transforms the multi-label problem into multi-class problem by considering each unique label combination as a separate class. Effective but struggles with large label sets. Then for classifier chains, it uses multiple binary classifiers where each classifier considers the prediction of previous classifiers, capturing label dependencies. Then kapag naman multi-label k-nearest neighbor, it extends naman yung k-nearest neighbor, so yung k and n, for multi-label task by analyzing label distributions among neighbors to make predictions. Then lastly is the deep learning model. It is the neural network like CNNs, RNNs, and transformers can handle multi-label classification by learning complex patterns and relationships between labels. So that is the multi-label multi-class. Moving on, for the common evaluation metrics. So for a bit of context, imagine you are a healthcare startup and you want an AI assistant able to predict whether a given patient has a heart disease or not based on its health record. This is a binary classification problem where the model will predict. So, yung 1 represents the true or yes if the patient has heart disease. Then 0 if wala siyang disease or heart disease. As you can see here, meron tayong tinatawag na confusion matrix. Merong TP, meaning true positive, then false positive kapag FP, which is also, other term niya is yung type 1 or yung error. Then kapag false negative, FN siya, then true negative, TN. Kapag false negative, type 2 error din siya. So, brief explanation lang kung ano yung meaning ng true positive. Imagine niyo na nag-grade kayo ng student test where they have to identify apples in a basket. If sinabi nila na this is an apple and it really is an apple, that's a true positive. They got it right. So, yun yung meaning ng positive. Correct, yes. Kapag naman true negative, yun naman yung correct no. Meaning, kapag sinabi na hindi ito apple, pero actually, hindi talaga ito apple, maybe it's an orange, that's a true negative. Also correct din siya. Kapag naman sinabing false positive, wrong yes, or false alarm, meaning kapag sinabi na this is an apple but it's actually an orange, that's a false positive. They made a mistake. So, false positive yun. Kapag false negative naman, ito naman yung miss, in other word. If they say this is not an apple, but it really is an apple, that's a false negative. They miss it. So, yan yung pinagkaiba nilang apat. So, wag kayong malilito. Next. Merong apat na metrics to compute the classification. First is yung accuracy. We get the accuracy by answering this question. Out of the predictions made by the model, what percentage is correct? So, hahanapin mo ano yung percentage na tama. So, yung calculation niya is true positive plus true negative divided by the total samples or yung total number ng observation. Next metrics is yung precision. For the precision, we get by answering this question. Out of all the yes prediction, how many of them were correct? So, yun guys, huwag kayong malilito. Huwag kayong malilito sa accuracy and precision. Si accuracy, kinukuha mo yung percentage ng tama ng kabuuan. Kay precision, kinukuha mo ng lahat ng yes ang predict or lahat ang sagot ay yes. Next metrics is yung recall. Aims to answer this question naman. How good was the model at predicting real yes events, which can be considered as the flip of the precision? Yung recall for the calculation naman niya is yung true positive divided by yung true positive plus false positive, Then the last one is for the F1 score. Sometimes used when dealing with imbalanced data sets, meaning that there are more of one class or label than there are of the other. It corresponds to the harmonic mean of the precision and recall. So, for the calculation of F1 score, it is 2 multiplied by the precision, multiply recall, divide precision, then add the addition of recall. So, yun siya guys. Huwag kayong malilito sa evaluation metrics. Next, meron lang ditong important note na dapat ninyong tandaan. The choice of algorithm depends on the specific problem, the size and complexity of the data, and the computational resources available. Lagi nyo tatandaan yan. Yung choice of algorithm ninyo nakadepende pa rin doon sa data or sa specific problem na meron kayo. Next is model building and testing. In classification, a model is first trained using training data and then evaluated on test data to assess its performance before making predictions on new unseen data. So, dito sa figure, may makikita kayo na word na train, validation, test set, tapos data set. Kapag sinabi nating training set, ito yung nagtiteach sa model natin by showing it patterns in the data. While yung validation, ito naman yung helps adjust and improve the model before final testing. Then for the test set, ito yung checks how well the model works on new or unseen data. Understanding the data splitting in machine learning. Example tayo, meron tayong 1,000 data set. Then yung training set natin is 60 to 80% nun gagamitin for learning patterns. For the validation set naman, 10 to 20% used naman for tuning the model, fine-tuning the model. Then the test set is 10 to 20% din for the final evaluation. So, mayroon tinatawag na the golden data set. Ito yung typically refer to high quality, well-labeled data that is reserved for critical testing or benchmarking. If yung 20% ng data mo ay hindi nagamit, it could be due to misallocation or improper splitting. So, sa example natin, if 1,000 data points yung available tayo and yung 80% doon or yung 640 data ay nagamit para sa training, then yung remaining na 20% or 160, pwede nating gamitin for validation or testing rather than being left out. So, yun siya guys. In model building and testing. Next naman is yung overfitting and underfitting. When we say overfitting, it occurs when a model is too complex and fits the training data very closely but performs poorly on new unseen data. Ang underfitting naman, it occurs naman when a model is too simple and cannot capture the underlying patterns in the data, resulting in poor performance on both the training data and new data. Para ma-fix natin yung underfitting, kailangan maging complicated yung model natin. On the other hand, para naman ma-fix natin yung overfitting, kailangan naman maging simplify ng model natin. So as you can see here in the image, dito sa top image na to, meron siyang x-axis and then y-axis. So yung x-axis represents the complexity of the model, then for the y-axis represents the error value. Tapos may makikita kayo dito na yellow na bar or section, it represents the underfitting. Then yung gitna is yung optimal solution. Then yung red one is yung overfitting. Dito naman sa baba, makikita ninyo, nakalagay dito sa y-axis yung output variable and then sa x-axis yung predictor variable. Sinasabi dito na yung model is too simple sa underfit. Example, meron lang siyang straight line and it fails to capture the data pattern. On the other hand, dito naman sa gitna, yung optimal, yung model naman niya correctly capture the trend. May makikita kayo dyan na may pagka-curve siya dito. Without necessary complexity, may makikita tayo dito. Then, the last is yung overfit. Sa overfit naman, masyado siyang naging complex, which fit noise in the data rather than the true relationship, leading to poor generalization. Ayun. Moving on, for parameters and hyperparameters. It is a model parameter variable whose value is estimated from the database. Parameters are the values learned during training from historical datasets. The values of model parameters are not set manually. They are estimated from the training data. These are variables that are internal to the machine learning model. Based on the training, the values of machine learning while making predictions, the accuracy of the parameters values defines your model skills. Coefficients in linear or logical regression and weights in neural networks are example of model parameters. So, magbibigay tayo ng scenario. Yung sample scenario natin, a car dealership wants to predict the probability that a potential customer owns a car based on their age and gender. They use logistic regression and analyze past data using SPSS. John, a 30 years old male, visit a dealership and they want to estimate the probability that he already owns a car. So, ito yung sample SPSS output. Yung X sub 1 represents the age ni John, which is yun nga, yung 30 years old niya. Then, yung X sub 2 naman represents naman yung gender niya, which is male. For constants, it is equal to negative 1.791. Then for B, age coefficient is equal to 0.016. Then another B is for gender coefficient naman, which is equal to 0.530. Then, substituting lang ito sa mismong formula. Then, after that, makalculate ikakalculate na yung exponential niya. Ito yun. Yung magiging result nito, makikita na yung probability using the logistic function. So, after nito, ang interpretation dito is that Jan has a 31.4% probability of owning a car based on his age and gender. So, ito yung tinutukoy na 31%. Yung naging result ng overall computation. And yep, that's it. That's the end of our discussion. But before that, magkakaroon tayo ng short quiz or activity about yung ating naging discussion for today. Hindi naman siya ganun kahirap, guys. So, if nakinig kayo or naintindihan niyo yung mga sinabi ko, masasagutan niyo din to. So, here's the question. Number 1, which of the following best describes classification in machine learning? So, for number 2, which machine learning category does classification belong to? For number 3, which of the following is an example of binary classification? Then for number 4, which algorithm is commonly used for classification? Number 5, what does an overfitted model do? For number 6, a hospital wants to develop a model to predict whether a patient has diabetes based on medical test result. What type of classification is this? For number 7, an online store uses machine learning to classify products into multiple categories such as electronics, home appliance, and gaming. Which type of classification is this? Then for number 8, a self-driving car is trained to recognize road signs like stop, speed limit, and pedestrian crossing. It must classify a sign into one category. Which classification approach is best? Then for number 9, a company wants to predict whether customer will buy a new product based on their past purchases and browsing history. Which algorithm is most suitable? Then for the last number, a chatbot is designed to classify customer messages into different complaint categories. Example, billing issues, product defects, late delivery. Some messages fall into multiple categories. What type of classification is this? That concludes my presentation. Thank you all for your time and attention. I hope you gain valuable insights from today's discussion. If you have any questions, feel free to ask.